In this lesson, we're going to go ahead and go over slope from a graph, looking at proportional and non-proportional examples. Okay, so we're going to start off and go over what is slope. So slope is the steepness of a line, okay, the rate of change between 2 points. It is also the ratio of the vertical change, called the rise, over the horizontal change, called the run. We're going to write this as a fraction in the simplest form. So the variable for slope is m. So m equals rise over run. So right here, rise is the up and down action, run is the left and right action. A linear function. So when you see linear, I want you to think of a straight line. So a function that creates a straight line, a linear function is not always proportional. If it's proportional, so proportional function will always start at the origin. Remember, this is the origin right here. So let's go ahead and we'll even label that. Okay, and then linear, so when you think of linear, I want you to think of a straight line. So a linear function is going to look like this on the graph, a straight line. If that perfectly went through right here, the origin, that would be proportional. If it does not go through, there we go. If it does not go through the origin, maybe it's just a straight line going this way, okay, then it is just a linear function, but it is not proportional because it crosses the y-axis right here at 3. Okay, so it crosses the y-axis at 3. Here's the y-axis. It does not go through the origin, so this one is not proportional. So I'm going to go ahead and just create some examples. Let's do 2 here. So one going through the origin right there. We're going to write proportional function. And then another line, we'll go ahead and use red. Maybe we do it here, and let's say this point is 1. Okay, it crosses at 1, and this would be non-proportional. And think of proportional, okay? It has to make sense with no extra charges. So this would be if I worked 1 hour, I make $5, it goes up. If I work 0 hours, I make no money. Whereas non-proportional would be like a plumber charges me $10 an hour to fix the job or to fix something, and there is a $20 service fee for him showing up. So if he works for 2 hours, he's going to pay the hourly rate, but I also have to pay him the fee for just showing up. So just showing up at my door, working 0 hours, there's already a fee. That is kind of an example of non-proportional. Now there are 2 types of slope we are going to talk about. So we have positive slope. It is going up from left to right. So positive rises or increases from left to right. Okay, and this is the line for the slope. The little guy is just an example. And then a negative slope. So a negative slope decreases from left to right. So, oops. Negative slopes are going to have a little negative sign. Positive slopes, you don't have to put a plus sign, but positive slopes will have no sign in front of them, and then negative, obviously, just like we do with integers, negative notes will be shown with a negative sign in front of them. Okay, now let's look at some examples here. So we're going to see, is this positive or negative slope? What is the slope? And then where does it cross at the y-intercept? Those are all information I'm going to look for. So with this graph right here, it is going up. So if I look from left to right, it increases. So I know that it is a positive slope. Okay, and also I said that slope was rise over run. So I'm going to look for 2 points where the graph crosses. So see, like example here, where the grid is exactly. I'm looking for 2 points on the graph that show that. So let's go here, and the next point it crosses is right there. So those are 2 intersections of the coordinate plane where the graph crosses precisely. So that's going to help me. Since I don't have an equation to find the slope, I'm going to look at the graph. So now I'm going to count. I said slope was rise over run. So I want to count the rise. So I start here and go 1, 2, 3, 4, 5. So I went 5 spaces up till I was in line with the next point. And now I'm going to count over. So I'm here and go 1, 2 spaces over. So the run, which is the left to right, is 2 spaces over. So I know that is a positive slope, so I don't have to put a negative sign at that. The slope is 5 over 2. I'm going to leave it in an improper fraction for slope. I'm not going to go ahead and turn it into a decimal, nothing. It is in its simplest form right now because I cannot divide both numbers by 2 evenly. I'm done with that. So now the next question that is asking, it says, what is the y-intercept? So y-intercept, here's my y line, it's the vertical axis. So where does the line cross the y line? Just looking at that, let's see, I have, so here's 0, -1, -2, -3, -4. So it crosses the y line at -4. So the y-intercept is -4. Or if I wanted to give the points of that, it would be 0, -4. 0 because if I'm crossing the y-intercept, the x number has to be 0 because it has to be 0 to be on the y line. And y-intercept means where does it cross the y-axis. Okay, looking at example 2. Right here in the middle. So it's going down from left to right. It's going down, it's decreasing. So if it decreases, my slope is going to be negative. And slope, which is m, which equals rise over run. So if I find 2 points that crosses perfectly here and here, actually. And now we count up, so it looks like it goes up 1, but pay attention right here to the information. Each square goes up by 5 because it goes 0, 5, 10. So the rise is not 1, it is 5. And then over 1 here, let's see, from 2 to 3 is still 1, so 1. So my rise is 5 and my run is 1. I know my slope is negative. 5 over 1 simplifies to -5. And lastly, look at where the y-intercept is. So it crosses the y-axis right here. And that number is 15. So the y-intercept is 15, or 0, 15 if I want to know the actual location. And looking at our last example here, from the left to the right, I see an increase. So I have a positive slope. Find where it crosses here and here. Okay, again, so rise over run. I write this out to help me remember what information is going where. So I rise from here to here, and that goes from 4 to 2. So that is 2. And then if I notice on my x-axis, those increments go up by 1. 1, 2, 3, 4. And that is 4. This should really go all the way to here because this was where we counted that. So 4 is my run. So my rise, I said, was 2. The run is 4. Which if I simplify, I get 1 over 2. So 1/2 is my slope. And then y-intercept is actually a point I've already used, but that is right here, and it crosses the y-axis at negative, oops, the pen to write it in, -4.